Hi, my name is Leroy Brown, but you probably know me as ENCH300. All my friends call me EB because I know everything there is to know about chemical engineering processes. There are many chemi things I really love to do, such as Navier-Stokes, Buckingham Pi, and cycle problems. But my favorite principle is the first law of thermodynamics, applying mass and energy balances. When it comes to solving chemical engineering mysteries, well, I'm willing to see if anyone is as good as me. What you are about to see are two mysteries that I played a part in solving.
I need help.
What is it? Kidnap? Murder? Blackmail?
My tank.
Take me to your tank.
Thanos is behind this. I have this hollow insulated tank, and it had 1,000 kilograms of water, and it was at a temperature of 303.15 degrees Kelvin when I left it last night. But this morning, I found out that 1 kilogram of water had been stolen. I think that Thanos opened the valve at the top of my tank and caused some of the vapor to evaporate. I suspect that this will affect the temperature of my tank, but I'm not sure exactly by how much.
It's okay. We'll get to the bottom of this. Hi, Thanos.
Yeah, Brown. You stole from my tank. I fixed it and you stole from it.
Oh, better. You're not a deal solution.
I put it right here. You saw me put it right here.
We've been using our tanks for weeks, right, guys?
Yeah.
I would like to hear more about that.
Oh, knock it off.
Are you calling me a thief?
Of course not.
Oh my gosh, it's not like 1 kilogram is that big of a deal anyway. It's only like, what, 0.6 degrees temperature change?
I'm just gonna tell you and I'm gonna tell the police.
Oh my gosh, let's get out of here, guys. Better watch your step, Brown.
What did you say to Thanos?
I just pointed out why I think they stole from your tank. I never said how much water was stolen or what the temperature change was.
Wait, there's a way to calculate the temperature change after you evaporate a certain amount of water?
Oh, young Padawan, you have much to learn. Here we have our time-dependent energy balance. Now, don't be too scared about it. Obviously, a lot of these values are going to cancel out. So tell me more about the tank so that we can go ahead and start canceling some of these.
Well, the tank was well insulated, it had no mass entering, and it had no work being done.
Oh, perfect. In that case, we can get rid of our Q, our W, and our entire mass entering values. So now we're left with what we got right here. Anything else that you can tell me about the system?
I don't think there was any velocity.
Was there any height change?
No.
In that case, we got a really, really simple balance for our final part. So let's look at what we know.
Okay.
We know that 1 kilogram left, that we started with 1,000 kilograms, and we were left with 999 kilograms. We can find our initial internal energy from the steam tables, since we know the temperature and pressure of a saturated liquid can only be certain values. And then we can use our internal energy for the liquid for the internal energy of the system, since it's all liquid. For our H out, since we're assuming only 1 kilogram evaporates, we're also going to assume that the temperature change is going to be small enough that the heat capacity will be constant and our enthalpy value will be a singular value. So now we're left with just solving for our internal energy of the final, what's left over in the tank. Since we assume that the final state of the water is going to be a saturated liquid, after we solve for our internal energy final, and we assume that be a saturated liquid, we can interpolate to solve for the final temperature using our final internal energy, which we just solved for, our initial internal energy, which is in our steam tables, and initial temperature. After we interpolate using one of the values from the steam table at 25 degrees Celsius and the internal energy at that point for the liquid, we can solve for our final temperature.
Wow, so that's how you solve for the final temperature?
Mm-hmm. And when we plug in all the numbers, we get a value of just a change of minus 0.6 degrees Celsius.
Okay, that makes me feel a lot better.
Someone's been messing with the temperature of my tank. I came back and the temperature of my tank was at 298.15 Kelvin. I know I left it at 303.15 Kelvin. I'm so sure the water has now evaporated from my tank, but I don't know by how much.
Wow. So I guess that eliminates you as a suspect as to who stole Black Widow's water.
Of course not.
Okay, let's get to figuring out how much water was lost. We can use the exact same energy balance. In this case, however, we know what the both internal energy values are since we know the temperatures at each point. And we also know that we can solve for the mass of water that was lost by using our initial mass of the system and our final mass of the system, our unknown being the final mass of the system. There's only one really big difference between what happened with your tank and what happened with Loki's tank: the enthalpy value. In this case, since we know that the temperature change is 5 kelvins, we cannot ignore the change in enthalpy which results because heat capacity is reliant on temperature. In order to account for this, we're going to take the average of the enthalpies at the initial temperature and final temperature to get a more accurate value of enthalpy, just for time's sake. If we wanted to be more accurate, we could solve for the heat capacity change directly by using the integral for the heat capacity and solving directly for the enthalpy. Once we have our internal energy values and our enthalpy value, we can solve directly for the final mass of the water left in the tank and use this value to solve for the amount of water that was lost, which leaves us with the amount of mass lost being 8.5 kilograms.
Wow, thanks, Brad. Now I know how much circular liquid to pour back into my tank.
See, this just confirms that Thanos is the culprit. How else would she have known how much was removed from my tank and the temperature difference?
To be fair, when Dr. Thomas, Dr. Doom, and I took ENCH300 in villain school, we had the same problem.
Well, are you gonna get to the bottom of this, Brown?
I have 2 suspects that I need to question.
How could they do this to me?
Villains will be villains. There's nobody here. They must have got away.
Want it. 100 miles of running through the rain and the sun, and when them fed folks coming. Keep your head up, youngins. Gotta keep your heads up, youngin'. The streets to get your head up, youngin'. Listen, click your contacts. Stay focused like contacts. Your head's open for a contract. Can't go with my mat. The last place you wanna bring the drama at. The first place they gon' track my promise. Can't relax but remain the calmest. Couple rules that you play by. Stay